Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give an example of rate of change, and the problem here is related to physics. So let's say we have a position function which is given by s. S is equal to a function here that depends on t, and this function here tells the movement of a particle in a straight line, and therefore delta S over delta T here represents the average rate of change of displacement with respect to time, or in other words we can say it is the average velocity over a time period delta T. Now, if you look at this expression, on the other hand, this expression here is slightly different, because here we have an additional term which is basically saying that let the delta t approaches 0, and we would like to find what's the limiting value of this expression here. So in other words, this term which we have seen on the left side of the equation here is equal to the derivative. So derivative of a function s, and it is also can be mathematically represented as ds dt. So here is the derivative, and the meaning of it is just instantaneous rate of change of displacement with respect to time, or in other words, it is the instantaneous velocity at time t. So that's the idea. That is the difference between what you are seeing here. So this is delta S over delta T, and on this part here we have additional expression which has the limit of delta T approaching 0. Okay, so those two terms are slightly different in terms of their meanings. Okay, right, let's look at the example given here. We have the function which tells you the position of a particle given by this equation here, and this equation here depends on t. The function here depends on t, where t is time and it is measured in seconds, and s is given in meters. And you are asked to find the velocity of this at time t, and according to the idea given here, velocity is just finding the derivative of the given function. So this is what you have to do. You need to differentiate the given function. So for question A here, we're going to find what is ds dt, and that is equal to differentiating the given function, which is t cubed minus 6t squared plus 9t, and the answer here is going to be equal to 3t squared minus 12t plus 9. So this is the velocity at time t. Okay, next we're going to find what is the velocity after 2 seconds and after 4 seconds. So for question B, velocity after 2 seconds is going to be very easy. You're just going to substitute 2 into the result that you have here, and therefore what you have is 3, and this is going to be 4. 2 to the power of 2 is 4, minus 12 times 2 plus 9, and this is equal to 12 minus 24, plus 9. So negative 24 positive 12 is negative 12, plus 9 is going to be negative 3, and the unit is meter per second. Okay, so here we have meter and this is seconds, so meter per second is the unit for velocity. Okay, so next is how about velocity after 4 seconds? Now velocity after 4 seconds, So this is going to be 3 times 16, 4 squared is 16, minus 12 times 4 plus 9, and this is equal to 48 minus 48 plus 9, and this is just 9 meter per second. Now I'm just going to highlight the sign given in the answer here. So for the first one here, we have a negative sign, and this one here we have a positive sign really. And since velocity is a vector, so I'm going to just write down here, velocity is a vector, and it has not just the magnitude, but it also has a direction. Okay, so we have a direction. So the sign here represents the direction, and if you have a negative sign, basically it is telling you that the particle is moving backward. And on the other hand, if you have a positive sign here, the particle is actually moving forward in a positive direction. Okay, right, now so let's check the time for when the particle is at rest. Okay, so the particle is at rest when the velocity is equal to 0. Alright, so velocity is 0, and we're just going to set this result here equals to 0, and we're going to solve it and find what's the value of t. So we have 3t squared minus 12t plus 9 is equal to 0, and here we can factor out 3, so we have t squared minus 4t plus 3 is equal to 0. Next, we can have t squared minus 4t plus 3 is equal to 0. And based on this, we can write this expression in terms of factors. So it's going to be t minus 3, t minus 1 is equal to 0. Therefore, t is equal to 3 or t is equal to 1. So these are the times when the particle is at rest. Okay, so let's move on to the next question. When is the particle moving in the positive direction? Alright, so for this purpose here, maybe you can try and visualize the velocity function given here. So this is the velocity function, and we can try to sketch how this function looks like, considering the fact that when t is equal to 3 and when t is equal to 1, velocity is 0. And of course, this is a quadratic function. Therefore, since the value here is positive, we know that the graph is going to be looking like this. Okay, so it's going to open upwards, or it's going to be smiling, as you can see here. Now, I'm just going to show you how you can sketch the function here. So we can imagine this is the vertical axis, which represents the velocity, and this is the horizontal axis, which represents the time. And we know that at this point, for example at point 1 and point 3 here, we have velocity 0. So we know that somehow the graph is going to touch the horizontal axis at this point. So it's going to look like this, since the graph is symmetric now, more or less like this. And the question is asking you to see the time, or to identify the time when the particle is moving in the positive direction. And again, we have talked about the idea of positive and negative direction. When velocity, so velocity here is a vector. So if you have a positive sign, that means it is moving in the positive direction. And if you have a negative sign, it's going in the backward direction. So in this case, we can see that this is the positive values. This is our positive values. And when it is at this point, this is when the particle stops. So it is not moving, it stops. Therefore, we can say that the particle is moving in the positive direction. when t is less than 1. Okay, next, if you look at this part here, the value of velocity is negative, so which tells you that the particle is moving in a backward direction, and this is not what our interest is, because we are really interested in the just positive direction. Yeah, and at this point here the particle stops, so it is not moving at all. Now on this part here, the value is positive, so we know that the particle is moving in the positive direction. So the time here, the time associated with this movement is going to be from t greater than 3. Okay, so to answer this question, what we're going to write is, we're going to say that the particle is moving in the positive direction when t being less than 1 and when t being greater than 3. So that's the answer. Okay, so next is, we are going to answer the next question, which is this one: draw a diagram to represent the motion of the particle. So perhaps we can start off with having a straight line here. Okay, and this is going to mark point 0. So this is the value of s equals to 0. This is the point of origin, this is the starting point, so s is equal to 0. And we can see that, okay, first of all, let us go back to what is the equation. So the equation is this one. So when we know that, when t is 0, s is going to be equal to 0. Okay, you can substitute t equals to 0 and you will get s equals to 0. Okay, all right, so I'm just going to write down this function here. S is equal to t cubed minus 6t squared plus 9t. So when t is 0, s is going to be equal to 0. So this is the position of the particle when the time is 0 seconds. Okay, right now, or maybe what we can do is, we can, so let me just use this as, sorry, let me just do it once again. So this is the line that represents the distance here. So this is at point s equals to 0, and this is the position of the particle at that point. Okay, right, so now we can see that when t is between 0 and 1, so here in particular, this is the point of interest. When t is equal to 1, the particle is going to stop. So you can see that based on the velocity of graph here, you can see that when t is equal to 1, the particle is going to stop and it is going to change direction. Okay, so we're going to consider when t is equal to 1, what is the position of the particle. So when t is equal to 1, s is going to be equal to, this is going to be 1 minus 6 plus 9. So negative 5 plus 9, s is going to be equal to 4. So maybe the position of the particle is at this point. So this is 1, 2, 3, 4. This is s is equal to 4. This is at time t equals to 1, and the particle is at this point, yeah, and t is equal to 1. The distance it travels is s equals to 4 meters. All right, now based on this velocity graph here, you know that at this t equals to 1, the particle stops and it is going to change direction. So now the direction change means the particle is going to move this backward direction. So now the particle is going to move in this direction from t between 1 to 3. So now the point of interest is when t equals to 3, we want to know how far the particle has traveled. Okay, so we're going to substitute 3 into this equation here. So what we have is s is going to be equal to, this is 27 minus 6 times 9 plus 27. Okay, so 27 plus 27 is 54 minus 54, the distance is going to be at 0 meter. So it means that the particle is turning back, and when the time is 3, it will come and reach this same position here where s is equal to 0. Okay, now next, based on the graph here again, based on the velocity graph here again, you can see that after time t greater than 3, the velocity here is positive, which means that the particle is moving in the positive direction, which means you can imagine that going in this direction and just continue along this line here. Okay, so that is the diagram to represent the motion of the particle. And perhaps what I can do is maybe I can connect this process so that it can be seen clearly. This is the direction. Okay, you can see that you can compare this diagram with the velocity function here. So from point t equals to 0 until t equals to 1, the velocity is positive, which means that it goes in the positive direction here, this one, and then it stops when t equals to 1. And from t between 1 to 3, at this point, velocity is negative, which means that the particle is moving in this direction. And when t is equal to 3, it comes to the same point, the origin point, which is at this s equals to 0. Now, it stops at this point. So here is also when t is equal to 0 and t equals to 3, yeah? So at this point here, it stops. When t is equal to 3, it stops. The velocity is 0. And after that, the value of velocity is positive, which means that the particle is moving in this direction, in the positive direction. Okay. Right, now let's move on to question F. Find the total distance traveled by the particle during the first 5 seconds. So this is t equals to 0, point t equals to 0, t equals to 1, now t equals to 3, and we know that after that it just moves along the positive direction. So now our point of interest is to find the distance when t is equal to 5. Therefore, when t is equal to 5, s is going to be 5 to the power of 3, which is 125, minus 6 times 25, yep, and then plus 9 times 5. So here we have 125, this is 150 plus 45. So s is equal to 20 meters. So when t is equal to 5, the particle is now at a distance of 20 meters from the origin, which means if this is 4, this could be 5, 6, 7, and blah 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 blah. 20 could be somewhere here. Okay, this could be 20. So the particle will be at that position here. The particle is at this position, and so just going to complete this diagram. This is at t equals to 5. So therefore the distance travel is going to be this. From this point to this point, the distance travel is 4 meters plus this point to this point is another 4 meters. It goes back to the point of origin, and then it turns to this direction for 20 meters. So the distance travel is 28 meters in total. Okay, that's all for now. Thank you very much for watching.